Okay, so today I'm going to talk to you about the X-class survey, which is a catalog of 1,646 X-ray selected galaxy clusters up to redshift of 1.5. This is a very recent publication. We published this catalog very recently within the framework of the X-class collaboration in the astronomy and astrophysics. This is a paper. And actually, the catalog is accessible through CDS and through our own database, interactive database, which I'm going to talk to you about in a while. So to start, to describe the catalog, first of all, we had more than 9,000 XMM Newton observations up to until August 2015. Which we were planned to process. And we ended up with 2,461 observations after a cut at 10 or 20 kiloseconds in order to facilitate the computation of the selection function. And this is actually the special point of this catalog, that it has, it's not just a catalog of clusters, of X-ray clusters, it has selection function. You can see here the layout. It's all around the sky, not in the galactic plane, excluding the galactic plane. And it covers a total area of 269 square degrees. For the processing, we have used a pipeline, a specialized pipeline, X-ray pipeline called the Examine 3.5, which is specialized in the detection and selection of extended X-ray sources, which are the clusters. And I have to say that actually the 95% of X-ray sources are actually AGNs. So this is difficult work to do, but this pipeline was dedicated to that. The cluster selection was based on purely instrumental criteria, and it was extensively tested via simulations. And here you see, for example, in this plot, you see the extent of the emission and the likelihood of the extent of this extent. With green, you see the point sources, with red, spurious sources, and with purple are the clusters. So the C1 that you see here, the class 1 clusters that we select for the X-class catalog, is supposed to be a pure selection. Of course, the reality is a bit different from simulations. So we have visually screened all candidates, and we have also then, after the screening, we have confirmed with spectroscopic redshift one by one all the candidates, all clusters. So this is a work that we have done at the National Observatory of Athens. We have separated also our clusters in 4 categories, the confirmed ones, which are most of our clusters. And these are if we have 3 or more galaxies with concordant spectroscopic redshift within the 500 kiloparsec radius from the center of the X-ray emission. The tentative category, where we have 1 or 2 galaxies in this radius. Photometric, if only photometric redshift information is available, and a few sources, 87 actually, which are we call provisional because we are not yet sure if they are true clusters or spurious detections or AGNs. So this is an example from the redshift validation procedure. Here you see on the left side, you see an X-ray cluster, the extended emission, and the X-ray contours. This is an X-ray cluster, and on the right side, you see the I-band optical image from pan-stars, and with the X-ray contours again overlaid. And with the red circles, you see the 11-member galaxies that we use to confirm this cluster at a redshift of almost 0.8. This is the final layout of the catalog all around the sky, more than 1,500 X-ray clusters plus the 87 provisional sources. The selection function, actually, this is not a flux, an exactly flux limited sample. So the selection is a function of count rate, which is a flux. Actually, you see it on this on the x-axis, and on the core radius of the cluster of the extended emission. And you see here the probability of a source to get detected and selected as a cluster based on these two values. This is one example of for exposure of 10 kiloseconds. Of course, we have 20 kiloseconds and various backgrounds. So we have various selection functions depending on the background and the exposure time. And this is the Redshift distribution of the sample. It peaks at 0.1 because we have a lot of pointed observations. And when I say pointed observation, I mean observations that that the targets are bright nearby clusters. So if we exclude those and we get only the serendipitously detected clusters, we get this Redshift distribution, which peaks at redshift of 0.3, which is normal for a cluster survey. We also included in our sample is a subsample followed up by spiders, which is actually the spectroscopic identification of Rosetta sources. With the SDSS 2.5 meter telescope. So these are actually 124 clusters which have more than 1,000 spectra in X-class red sequences. So there is a lot of information there for this subsample. Also, we have measured by with a dedicated software, one by one again, we have measured the fluxes. So except from the fluxes that we get from the pipeline, the automatic measurements, we use this flux measurement tool where we can refine the X-ray cluster center, the masking, and other things. And we find the profile and we measure the fluxes in 6 different X-ray bands. So all these informations are given in the database, and I will show you. We have also compared our with previous cluster catalogs. This is a Redshift comparison. The agreement is very good, and actually for the outliers, we have checked the outliers. We have them usually we have the most updated information, so our redshifts are very good. And this is a luminosity comparison with previous XCS sample. In order to see if we are biased due to our cuts or to our pipeline, if we are biased towards higher luminosity or lower luminosity clusters, but everything is checks out, it's okay. And now I will just tell you about the database. So the database is now public with a catalog and the paper. So everybody can register. You don't need to be members of the X-Class collaboration to access the data. This is the first page that you will see. You can select your own subsample, selecting with different coordinates, various coordinates, or X-ray properties here, or other criteria like the redshift, minimum redshift, maximum redshift, or status, confirmed clusters, photometric clusters, whatever you want. And when you select your sample, you can display the catalog. And here is a part of the catalog, of the full catalog in this case, where you can see basic information like the coordinates, the redshift, the status, confirmed, photometric, etc., and the fluxes. But there are links to various pages that give you access to all the information that I have mentioned before. For example, if you click in the X-class number, the sequence number, you get access to pipeline products. You get access to X-ray images, the detections, the contours, the product, the results of the pipeline, also images in of different XMM detectors and details of the X-ray um, processing, like the event files. So everything you need. Then if you click here that says NED, you get access to this page that draws information from directly from the NED. So it gives you back all galaxies or clusters that are already public in the NED database within 3 arc-minute radius, and you can visualize actually the image from whatever survey is available there. Here, for example, is from the pan stars that we used a lot also for the confirmation, the Redshift confirmation of our clusters. But you can select whatever else other surveys.
You have 3 minutes.
Okay, I'm close now. So there is also the Redshift page where you can, the Redshift confirmation page, you can see information on how many clusters, how many galaxies we have used for the cluster confirmation, for the Redshift confirmation, the coordinates of these galaxies, as well as Redshift histograms. You see here the peak of this number. This is the number of galaxies that were used for this cluster. And finally, here in the profile, you can see the data that we have used for the flux measurement, the interactive flux measurement. You see where the background was chosen, the mask, the profiles, and plus the 6 X-ray bands and the respective fluxes. So the conclusions are basically 2 conclusions. First of all, because of its homogeneous selections and thorough verification, this cluster sample can be used for cosmological analysis, but also as a test bed for upcoming Eurozeta observation and other large area cluster surveys. And it is the first time that such a catalog is made available to the community via an interactive database, which gives access to this wealth of supplementary information, images, and data. Now we plan to exploit for the scientific exploitation of this sample, which we have already done with previous samples, but we continue now. And we are planning on processing all data up to today, 2021, because as I told you, we have stopped in 2015. So I leave you with some of the main publication of the X-class collaboration. In the first paper here, you can find all the details that I talked about today, but many more. In this link, you get access to the database that I showed you without being a member of the X-class collaboration. But if you have ideas or if you want to join the collaboration, please send me an email to this email here on the bottom, and I will be glad to discuss. So thank you for your attention, and that's all from me.
Yes, thank you, Leah, for letting us know of your work. It is quite extensive. I don't say we have questions, and no raised hands, at least up to now. I was wondering a little bit about stellar masses for all of those. What do you think of a percentage of what coverage do you think you'll be able to get in the end? And so on and so forth.
So about the cluster masses?
And individual galaxies in them, I guess. Cluster masses will be harder to get. I guess both are interesting indeed, but I was more thinking when I asked you about individual galaxies in them.
Individual galaxies. I mean, this depends on the redshift of the cluster.
Of course.
Yes, we have many clusters, low redshift clusters, but we go up to redshift 1.5. Of course, this is much more difficult to get. But the redshift distribution peaks at 0.3. So
you would be able to identify individual objects. That's what I'm curious about. If you were
individual objects, you mean
individual galaxies within each cluster?
In the X-rays?
No. No. Of course, the complementary data.
In the optical?
Yes.
No, it's very easy to see the galaxies in the individual galaxies up to redshift 1 with these surveys. I
I was
mean,
wondering whether you would have some interface to like provide this information, like for this cluster, these are the members and so on and so forth, something like that. And the Stara mass is this. And
I mean, even if you go to, as I told you, if you go to the NED page and you visualize, you can see the cluster and individual galaxies, and especially if you have pan stars in the north, you have pan stars for sure. For half of the clusters, you can see individual galaxies up to Redshift 1 for sure.
are all of them reliable? I mean, every time we cross-match things with net, we have to do it also manually eventually to be sure that, you know, this is what it is. So I was just wondering if...
Well, for redshifts, I mean, yes, we know that redshifts are not all the times reliable, but we have checked one by one and we have discarded the unreliable information. Of course, if there are redshifts in the SDSS that are unreliable, yes, of course, there are. But we are trying to discard this information.